So let's get started with this. So why is calculus important for AI? So the example I want to give you initially is neural networks. And the reason I want to start with this is these are kind of all the rage these days. Everything from ChatGPT to Midjourney and pretty much any major AI service that you can think of is using a neural network under the hood. And to really understand what a neural network is, I think it helps to take a look at biological neurons, which are kind of very loosely the inspiration for neural networks. Neurons look something like this. They have a nucleus enclosed in a membrane, and at the top here, they have something called dendrites, which is where they receive incoming signals from other neurons here. And then they have this long tail called an axon, which at the end has a terminal where this neuron will connect to other neurons, and it can connect to multiple neurons here at the axon terminal. So let me label some of these for you. So these are dendrites, where again, the neuron gets inputs from other neurons. Then here's the axon, where the signal of this neuron is going to travel to other neurons. Here's the axon terminal, where that signal will jump to other neurons. And I'll draw one neuron down here as an example of a neuron connecting to this top neuron. So the dendrites of this neuron are connected to the axon terminal of this first neuron. And they're not actually connected. There's a very tiny little space there, but we don't have to go into too much detail about that. So how this works is an incoming signal comes in here from another neuron, and if that signal excites this top neuron enough, it's going to decide to fire an action potential. And when it does that, an electrochemical signal is going to go all down through this axon to the axon terminal, and then it's going to pass on to this neuron here. And the reason that this is important is that the more often this neuron fires a signal to this neuron, what's going to happen is this connection they have here is going to strengthen. And that's really important because to our understanding, that is how learning happens in the brain. Okay, so now we have a really loose idea of how biological neurons work. How have these inspired artificial neurons? So if we take a look at a neural network, it's going to look something like this. So there's going to be multiple layers. We'll call this the input layer. And then we'll call this layer 2. And then we'll call this final layer the output layer. And there's just going to be one neuron in this output layer and in this example. So each of these circles is an artificial neuron in a neural network, and they can be connected. So this neuron passes its signal to this top neuron here in the second layer, and also this neuron in the second layer, and this last neuron in the second layer. And the second neuron in the input layer can pass its output to this top neuron, and this one, and this one. And finally, all of these in the second layer pass their outputs to this neuron in the output layer. So there's some similarities here. All neurons, just like in all artificial neurons, just like in biological neurons, have some sort of input coming in, and they send an output to another neuron, or a group of neurons. They can send outputs to multiple neurons. And internally, they have some sort of logic to determine what it is they're going to be sending to that next neuron. In neural networks, how this is determined is by some sort of mathematical function. So, for example, this neuron can have some sort of mathematical function inside of it. And every single one of these neurons, this one, this one, this one, this one, every single one of these is going to have some sort of mathematical function which determines what it's going to pass on to its output. But what's really important about this function here, what's really important to look at is this term W and this term B. The function that's inside every neuron, every single one of these is going to contain this variable W and this term B. And what's very important is these terms will be made either larger or smaller using calculus to either strengthen or weaken the connection of, say, this neuron with all the neurons that it's connected to. And that process is done for every single one of these neurons. This neuron will have its W and B adjusted, again, using calculus to be either strengthen or weaken each of these connections, and same with this neuron and this one also. And similar to how in biological neurons, we think that learning happens by strengthening or weakening these connections between neurons. Similarly, that's how it happens in neural networks. We adjust these terms W and B using calculus to either strengthen or weaken the connection between two neurons. And that's why calculus is so critically important to learn if you want to understand deep learning.